So as I said, my name's Kevin Main. I'm the tools engineer that's principally responsible for maintaining Battery Management Studio, BQ Studio. Today, I have a little bit of an introduction for those of you who are unfamiliar with what BQ Studio is and what it's capable of, but also to talk about some of our longer-term plans as a platform and how we're using that through the broader Battery Management Studio product line, not just gauging. I'll talk specifically a little bit about how to use it for gauges, some of the features of automation, talk about design completion for your systems and integrating your implementation of the gauge configuration or the charger configuration into your platform. And then provide a few useful links at the end. The last bit is feedback and questions, which is of principal importance to me. I'm just an engineer. I don't get out of the office that often. So the opportunity to get direct feedback on feature set and what's confusing and what's not, what could be enhanced, that's what I would love to hear from you today, certainly. So to start out with introduction, installing BQ Studio, you've seen this link before in a number of the presentations, but ti.com/tools/BQ Studio. There's an export control form to download and complete if that's applicable to your situation. You do have to have administrative privileges on the system in order to install it. That's principally because we have some driver architecture associated with supporting the EV2300 adapter that requires administrative privileges, but there's also some static libraries and things that have to get installed and registered, and that does require administrative access. But the installer requests that automatically, so as long as you're a privileged user on the system you're using, it shouldn't be an issue. You just click through the process. There's a standalone, if should you need it, EV2300 64-bit driver from, it's available through E2E. There's a link up there, but also I'd search for it on E2E for the location, because that's not a permalink. So if you're using the EV2300 in a 64-bit environment and you have administrator privileges on your system, there's a standalone 64-bit driver for support for that, should that be necessary. But most of what we do today going forward is around the EV2400, which doesn't require any additional driver support in Windows. It just works as is. So BQ Studio is the proprietary TI battery management really solution suite of tools that scales all the way from simple automated operation, like you saw with Battery Management Development Kit that we're working on if you looked at the previous program or saw that just before lunch, all the way through really advanced configuration and tools and debugging and verification. It supports not only gauges, but also chargers, protectors, monitors. You should protect your system. The idea is a single suite of tools that's extensible and flexible and supports the full product line, supports the full ecosystem in a way, so if you're using multiple products, we can deal with that gracefully in a single application. Its function is to help you evaluate Battery Management Solutions products, to implement them in your system, to program them, calibrate, configure chemistry and so on, set it up for your platform requirements, and then validate the configuration to make sure things are working the way that you like. And this involves both workspaces, views, and plugins. You saw one example of a workspace with BMDK earlier. Battery Management Studio is built on Eclipse, which is an open source Java platform that it's flexible, it's configurable, it's used for a variety of applications in industry. It's well maintained. And it gives us a long-term trajectory for cross-platform support should we want to implement that and develop it based upon customer requirements. But right now we target Windows, of course. It's robust, it's efficient. We have a C++ and Java-based framework within Eclipse that's used for all hardware communication across BMS. And so that library gets utilized in our entire tool set, both internal and external. And so it gets really wrung out and is efficient and well thought out. Then we have Java-based plugins running within the Eclipse environment that provide specific functionality for particular devices and product lines based on the particular hardware that's attached or the product that you want to use it for. Each plugin is contained within its own workspace tab. I'll show you a high-level picture in a minute. And workspaces and views are customized to specific devices. So if you're using a charger, it looks like a suite of charger applications. If you're using a gauge, it's a suite of gauge applications, again, tailored specifically to the device you're using. For gauges, of course, basic functionality, low-level functionality. We do reads and writes of registers. We do reads and writes of data flash or data memory locations. We can load and save those from files. We can restore the defaults if something is, you're not sure what's going on and you want to get it back to a factory refresh state. We can do that very easily. We have logging support with configurable sample rates. I'll talk a little bit more about that in a minute. But logging of both registers and data memory. We can send commands manually. There's an advanced comm plugin if you want to do low-level hardware communication. Test out a sequence of low-level commands that you might be wanting to use in a production environment. You can reproduce that with the advanced comm plugin. BQ Studio supports I2C, HDQ, and the SM bus communication. And there's additional plugins apart from just basic low-level functionality to assist you in the process of integration. So you can update the firmware, for example, the programming firmware commands. Or there's a commands plugin for doing things like seal and unseal and sleep and so on, issuing straightforward commands to the gauge. Watch and data graph plugins lets you watch and graph specific parameters or registers along the way so you can see what's happening in the system. Specific plugins for calibration, chemistry, or walking you through a process of question and answers questions that need to be answered in order to configure some of the more advanced, highly accurate gauges specifically to the needs of your platform. There's plugins for dealing with authentication, SHA-1, SHA-2, and so on. Learning cycle and GPC cycle, I'll get in a bit more detail here in a few minutes. And then the production-ready process, which involves goldenizing, golden image, and GPC packaging for CEDV gauges. I'll talk about that briefly as well. So here you see this is this is a single cell EVM in this case hooked up. You've got a simple, in this case, a 4-wire cable that's hooked up through the I2C, in this case, COM interface. It's going to whichever adapter you're using. It can be EV2300, EV2400, something similar, and then your pack hooked up to the EVM in that scenario. So that's the basic setup. In the case of a gauge, if you hook this up and run BQ Studio, it should auto-detect the gauge that you have, load the configuration, and automatically bring you up with something that looks similar to this. So this is the high-level gauge layout for BQ Studio. You see immediately available are the registers for the system. These are the initially sampled values as BQ Studio launched of all of the registers. These are the bits specific to registers that have fields or command bits or status bits associated with them. Here's the commands plug-in over here. So if you want to issue low-level commands on the interface, get the KIM ID or get the hardware version, firmware version, the output of that will show in the log panel down here. And then, of course, the dashboard, which I'll get to. The additional functionality available for the device that you've created is all available through these icons up here. So these are all additional plugins for goldenizing, for converting to HDQ interface in this case. Or there's the advanced comm I mentioned, chemistry programming, and so on. So by simply pushing the buttons, you can open the additional functionality. And this is an active, manageable workspace. So you can dock things and scale things and create a workspace that's usable for what you're doing at any given time. I'll talk a little bit about the dashboard you saw there on the left for gauges. It's open and monitoring. It allows you to do to get an instant glance to know that this is what's going on in the system. It's hooked up through this adapter. This is the gauge that's attached, and here is its current readings of current voltage, temp, and so on. So it gives you a snapshot of what's happening in the system. It's updated every 4 seconds. It does do some tracking in terms of a bit of a heartbeat. So if you're doing things at a low-level communication point and you want like atomic or fixed access where nothing else is going on in the communications interface for what you're doing, you're going to want to disable that. I'll show you that in a minute. But be aware that the dashboard is there and it's monitoring and it's tracking and it's reading in much the same way that a platform would read voltage, temp, current, etc. on a regular basis, as well as state of charge and so on. Some significant problems in the past with the dashboard interfering with log functionality, specifically if you had a kind of long wires connecting to your COM interface because you were debugging. If there was a COM error, the dashboard could get confused and freeze the logging. We did a lot of enhancements to the dashboard about a year ago to resolve most of those problems. So unless you're doing low-level COM or high-frequency, high-resolution logging, the dashboard probably won't interfere with you. But nonetheless, you can, by clicking on the top, auto refresh is on by default. Unless you're using an HDQ gauge, it comes up disabled by default in HDQ. But you can just click that to turn off the auto refresh, and that effectively locks the dashboard so that it's not doing anything at all on the communications interface. That means if your hardware goes away, it may still look like there's something, right? It freezes the input, and it no longer has any activity on the bus. There's an advanced view, which is useful if you're really trying to learn how the gauge works, or you know how it works, you know specific what you want to do. Under the Preferences menu under Windows, so you go to Window Preferences. There's several different options here for the various plugins, but under All Global Settings, there's an Advanced View option. For the registers, the advanced view gives you groups of 16 bits, and it lets you, this is really the important feature I'll mention, it lets you customize the registers that are logged and scanned by the register plugin. So if you want to really whittle down to a really high frequency log just for VIT, for example, or IVT, then that lets you kind of select just down to that parameter set. So here's an example of the 16-bit fields and so on. You'll see these additional checkboxes, a little hard to see from there, but the log scan option for those fields, basically ticking those on and off will include those in the scan, refresh, or in the log itself. So the idea of a log is simply a periodic scan that's getting saved to a file. Scan is simply periodically scanning all of the registers and updating the UI itself. The data memory, which is in Flash or depending on the gauge, but the data memory parameters are kind of more static. This is where your gauge kind of configuration space is as opposed to the operating conditions. Very similar, so you can see the individual classes of parameters. So there's configuration, gas gauging, security, and so on for this particular gauge. And then you've got groups within that of parameters themselves and then individual parameters. So for example, CC gain here is 9.999. And this shows you the state. Just like the register window for parameters that are read-write, you can go through this interface, click on it, update the value you want, and it'll get written to the gauge. In advanced view, data memory adds the subclass ID, block offset length, and importantly adds address length as well as native units. Some of the parameters are stored in the gauge in a way that is not consistent with the units that you typically want to use it in. And so BQ Studio automatically does that translation, but if you use advanced view, you can actually see the low-level content in the gauge and the units that are used to speak directly to the gauge as opposed to having that worked through a conversion or formula for the sake of usability. And the importance of address and length or subclass block offset, again, is that gives you information that you can then use to build command sequences if you want to in your own environment, in your firmware, in your software, or your production environment, do low-level commands. So for example, for this gauge, you can see these are the subclass IDs, the block length, the number, and the offset that's available to you if you want to update or read any of these particular parameters on the COM interface at a low level. I mentioned logging at a faster rate. By default, again, we're in the preferences window here. So Windows preferences, that was show advanced views. If you look at the register setting, there's a setting up here for scan log interval. In this case, I've set that to 1,000. That's not the default. But you can set this down reliably to 1,000 for many gauges if you eliminate all other COM activity by disabling the dashboard, whittling down the number of parameters. That allows you to do really high-resolution logs. As again, I said, for the critical parameters, like you want to do temperature, voltage, and so on. You can see here in this example, all the other fields in advanced view have been unchecked. So when the log or the scan is running, it will only specifically read, in this case, temperature and voltage, and it'll store those in a file. So here's an example of what that looks like. It's a comma-separated format, so you can parse this pretty easily in your own tool if you like. So there's basically a date-time stamp. There's a sample iterator indicator number. There's an indicator of how many seconds have elapsed since the log was started, and then the raw data that's read out of those values. And then an indicator of success or fail. If there's a fail, it'll indicate fail, and there's a failure log that's generated, and it points you to that when that happens, so you can get more detail about what went wrong. Talk a little bit about calibration. This is quite common to use for most gauges, single cell and multi-cell, but the calibration plugin allows you in multiple steps or all at once to calibrate CC offset, board offset, calibrate your temperature, current, and voltage. This is a single cell example of that. So this gauge has internal and external temp. You can calibrate each individually based on how the gauge is configured. It's showing you in real time the status of the gauge. So it's showing you what the gauge sees as temp, voltage, current, and so on. And then you simply indicate your calibrated, fixed, known, good, current, voltage, temperature number. Check that you want to calibrate, which entries you want to calibrate, and hit calibrate, and it goes off in the process of doing that. You've heard a lot about chemistry if you've been in some of the other more technical tracks. So the chemistry files are required for the impedance track gauges and many of the CEDV gauges. Chemistry files basically contain, at a very high level, the characteristics of the chemistry within a particular cell or battery. So each chemistry, in our case, is identified by a unique chem ID that's tied to manufacturer and model and so on. And the chemistry plugin allows you to program these. In this case, for this gauge, you can see there's a list as you launch the chemistry plugin of all the manufacturers, the models associated with that, and the chem ID number, and then the description. One question I know that comes up is the chemistry ID, really, the number itself indicates a unique chemistry. So if you see multiple chemistries with a particular ID, and you're like, which manufacturer do I use, or which model number, they're all equivalent if the ID itself is the same. So you can select the particular chemistry you want, say program selected chemistry, and off it goes. I want to mention, because this is important, under the help menu, there's update chemistry. We're updating this on a regular basis as we get new data for new cells, new packs. That's getting added, so you can follow the link through the help update chemistry to get a chemistry updater, so that you don't have to reinstall the whole of BQ Studio or get the exact freshest, latest version of the chemistry database. You can do that through there. You can also go to ti.com tools/GPCchem to get the latest chemistry tables. I'm going to talk briefly about automation. So there's a few basic plugins, but I want to talk about the ways that you can do some automation with all gauges in BQ Studio. So for a lot of our single cell gauges and a handful of multi-cell, we have this learning cycle plugin. It operates in 3 different modes. If you're using the GDK, it can do that. I won't go into detail for that today. But the distinction between manual and automated mode is essentially how much user interaction is required during the learning cycle process. So at a very high level, what you're doing is you're discharging the battery to empty. Then you're going through a full cycle, basically charge to full, and discharge with some relaxed periods in there, depending on the requirements of the hardware platform you're using. For manual mode, there's basically user prompts to guide you through that process. So it instructs you to connect your load so it can do the initial discharge. It tells you when it's relaxing, and it says, okay, now I'm ready. Let's attach the charge current so you can apply the charge current. It begins the charge portion of the learning cycle, et cetera. So it walks you through the process prompting you as the user to do this. For automated mode, it can use additional available pins on your adapter, whether that's the 2300 or the EV2400, and we provide schematics and documentation on how to do this, and a number of the gauges have on-screen prompting if it's supported for the gauge to show you exactly how to hook this up. But the idea with automated mode is we can use additional pins on the adapter that are automatically toggled so that you and your environment can switch on and off relays and automatically apply the charge and discharge cycles as it goes, which means that the learning cycle process for impedance track gauges becomes kind of set it and forget it. You can just start the process off and let it run. The relays will toggle your charge and discharge cycle, and then in the end you've got a usable log. Once you select one or the other, manual or automatic, then you can basically set up the particular parameters for the learning cycle you want to run. This is automated, so it's saying, okay, I want to use this as the load control pin, and this is the charge control pin. Depending on the adapter you use, it'll give you the available options, and you can test them. So once you hook up your environment, you can use those test buttons, and it'll toggle the pin so you can watch it toggle and make sure that you're ready to go. Then there's the charge setup and so on. So for the charge, there are various, depending on the gauge, there are charge termination options and discharge termination options. How does it know when to move on? When is the gauge fully charged and when is it fully discharged? And how is it learned? And then the control panel itself, there's basically a start button with an output log. For the GPC cycle, this is for the CEDV gauges that are going to use the gauge parameter calculator available as the web tool. Again, a very similar interface. So you set up the discharge condition, the charge condition if it's applicable. There's an important new window when you run the GPC cycle, which is to specify the log output location. Because with learning cycle, you kind of generate your own log for the parameters that you want if you decide you want to do that as part of your learning cycle. But logging is kind of optional. For the GPC cycle, it's required if you're going to use the gauge parameter calculator. So the logs, you'll specify an output location, and it'll generate the logs as you go. The current version of the tool walks you through the sequence of cycles that are necessary for the GPC to do the best job, which is different loads, different temperatures, and so on. So there's a sequence of 6 cycles that have to be fully completed. And depending on whether you're manual or automated mode, it'll either walk you through that process as a user step by step, or it'll automate portions of those cycles and then prompt you to do things like change temperature, However, I want to mention I can't show screen captures. It's something we're working on now, but for early next year, we have a lot of user interface enhancements coming to both Learning Cycle and CEDV Cycle, or GPC Cycle. Much better status information in terms of showing you where it is in the cycle, some immediate visual feedback so you can see, okay, this is about how much long I have left, and this is where I am in the cycle, and it's relaxing, and here's the last, or real-time feedback of what voltage and current it's reading. So lots more robust feedback over the process of the learning cycle or the GPC cycle, as well as for the GPC allowing random access. So rather than forcing you to walk through all of the cycles in a particular process, it'll be able, once you specify your log output location, it'll say, okay, well, you've already ran these particular cycles. So here, here's what's left that you need to do. Which one of these do you want to start, and let you kick off that process. Again, still in a manual or automated fashion. So again, I can't show it yet, but watch for that coming very soon next year. Briefly, I'll mention autocycle. For multi-cell gauges within the register plugin, there's an ability to do autocycling to basically in a very similar way to the learning cycle plugin for single-cell impedance track gauges. You can control charge and discharge through a number of ways. Basically, it monitors the state of the gauge. So if you, again, the Windows preference menu, if you look for the registers, if that's available to you, it'll have conditions to start the charge and start the discharge. So you can check your options here. Relative state of the charge drops below 7%, or battery voltage drops below 11 volts, or so on. And you can specify some additional values. And then this is important. Take action when any condition is met or all condition is met. So the termination of the charge and the discharge is based upon the configuration that you set up in these two windows to run the auto cycle. And again, that's all managed by the registers plugin for the multi-cell. Because most of the multi-cell gauges, we have a handful of multi-cell gauges that are supported in the learning cycle plugin, but many of them are not. A little bit about design completion. If you use the GPC cycle or you generated your own logs and you want to run the GPC packager, this is the way you take those logs and wrap them up in a way that you can use the gauge parameter calculator tool on the web. So in this case, there's 6 log files it's looking for. 0 degree C discharge taken with average max discharge, half average max discharge, again at 0, 25, and 40. So these are the 6 logs that you can specify. You give it an output file location for your package. You can configure the number of cells, SOC percent, where FCC learned, and so on. Set up a few parameters associated with your system. Load the log files into memory, and then at the very bottom is this generate package button that will create a single file that's a package that you can then take to the gauge parameter calculator online. So this is the way within BQ Studio that you would generate the input to that for configuring the ChemID and so on for your multi-cell gauge, or single-cell or multi-cell gauge that uses CEDV. For single-cell gauges, there's a Golden Image plugin that creates output formats that can be used to program other gauges to make copies of your configuration or even in your production environment. And the available output formats is gauge dependent. So again, for this particular gauge, there's opportunity to output an SREC, a BQFS, a DFS. Those are all flash stream formats. The FS files are used in different ways. What's important to understand about FS files is they represent raw bytes that one could then put on an I2C or HDQ interface to perform that programming functionality. So that's something that's a very versatile format that you can take into your production environment to program gauges, or in your operating system environment to program some of the parameters at runtime should you want to do that. Each of the file formats may offer options depending on the gauge and the format itself. So for example, by default, all these formats output I2C commands, but for gauges that support it, you may want an HDQ format version of your flash stream file, for example. There's options like including a go-to-ROM command, including execute, if that's applicable for that file format. But again, all that is under the options for each individual file format. So the main thing is hit the browse, pick an output directory. If you want to change any of the defaults, you can. Check the files that you want or don't want. They're all checked by default. Hit create image files, and then you've got exactly what you need in terms of golden images suitable for your production environment. I want to mention a little bit about OTP, one-time programming support for the ROM-based gauges that use OTP for configurability. There's a flash stream format called OTFS, or OT.fs files, specifically for the one-time programmable memory. Again, it's a flash stream format, so you still see those raw commands that would go out, the bytes that would be written in a raw fashion to your I2C interface, I2C interface. And we do provide a separate tool called Smart Flash that you can use that'll detect the hardware, let you load one of these OTFS files, and program the chip. What's different about programming OTP, the OTP gauges generally are ROM-based. So you're not programming firmware, but you're programming the configuration. You can alter the default configuration. What's significant about programming OTP is in your production environment, you've got to apply a programming voltage for a particular amount of time within a certain tolerance. This tool, of course, documentation can walk you through that. This tool specifically prompts you, okay, now, apply the programming voltage, now remove it, and so on. One other thing that's important about breaking out the Smart Flash itself as a separate tool is this is something that we can make available to you in terms of source code. So if you'd like to integrate the OTP programming process into your own tool set for production, this is a C# tool from the ground up, communicating through an adapter, inputting the FS format and programming it to a gauge through one of those adapters. So there's C# source code that will be available to you if you want to do integration with that. And I'll mention just offside, this is also a command line tool. So if you can pass in an FS file as a command line parameter, and it simply runs as a command line tool if you want to just use it in your production environment in a script-driven way. But if you run Smart Flash without any command line parameters, then it pops up as a GUI. So it works both ways. The function of BQ Production is that it's a tool that's more suitable to a production intent or production environment that's built off the same hardware communication framework as all of the other tools. So it's robust, it's extensible, it supports many of our gauges, particularly multi-cell. You need an MTester board for most of the functionality, and we do support both EV2300 and now we support EV2400. The latest versions of BQ Production will do that. And unless you've got specific questions later, I would say we probably will defer to the following program in terms of production tool set before I get more into that. Really briefly on chargers, because I focused a lot on gauges. So for chargers, again, we get to read and write all the registers through the workspace associated with the charger product line in BQ Studio. You can save all the register contents. We've added logging support recently. You can send commands manually using an advanced COM plugin. So same with gauges. If you want to use low-level COM for chargers, you can do that. Select your target address. There's 8 and 16-bit charger register support. Recently added 16-bit support for that. And again, support for I2C and SM bus on chargers. And then Watchdog support. Just to real quickly give you an idea, the default charger view, on the left you see the registers themselves, the address, the current value in both hexadecimal and a binary representation. On the right is a more usable, user-friendly implementation of what's in that register. So a value of 82 in this case corresponds to 4.25 volts in the battery voltage control register. So you can see you can change it anywhere and the value changes. So there's a drop down here for allowable values that allow you to update the contents of the registers. This toolbar up at the top provides all of the core functionality, so you can save or load the registers. You want to save a configuration file, put in another gauge, or put in another charger, and then load that. The same configuration, you can do that. You can start logs, you can read all the registers, write the registers, and so on. There's an auto-read functionality that's very similar to scan on the registers plugin for gauges. Update mode just determines the behavior of the GUI. Immediate mode means as you make a change, it's actually written to the charger and so on. And then this is how you would select your target address for the chargers that allow you to have options to specify the charger address there. There's also, there's a button at the very far right here on the toolbar that says Field View. If you switch to Field View, it gives you a view that's kind of more in keeping with all of the available fields associated with those registers. So it's a more kind of intuitive way of interacting with the contents. If you don't want to look up, okay, this register and this address has this particular value. This is a way to specify here, charge current, input current limit, sysv out, and so on, with the allowable options checked, and then basically your configuration space is updated on the right to reflect all of your selections in the left panel. So again, just another way to get at communicating with the chargers and configuring it in the way that you like. A few final useful links. Again, BQ Studio, I gave you the link already. BQ Production, you'll hear more about shortly, is available also at ti.com/tools/BQ Production. If you want to use BQ Production, you'll need an MTester board, most likely. So you can find out about that at ti.com/tools/BQMtester. I didn't do a deep dive into the GDK, which was the single cell version, kind of the first version of what we think of as the BMDK today. There is support for that built into BQ Studio. If you use the GDK, there's a suite of tools available to help do automation and chemistry idea selection and that sort of thing using the GDK as well. If you're using EV2300, please switch to the EV2400. But if you're using an EV2300 in a 64-bit environment, you'll need a standalone driver for that. And then the generic link for battery management tools.